In this video, we're going to solve each problem and graph the solution on the coordinate grid. For the graph, you can use the graph provided, this graph, or we can screenshot decimals with the labeled axes and scales. That's the one I'm going to really show us today. Or you can screenshot the TI-84 calculator graph and make sure you put the window that you used and the y equals equation. Let's take a look at number one. A concession stand charges $2 for hot dogs and $3 for brats. They want to make a profit of at least $500. Start by writing an inequality that represents this situation. Take a moment and figure out what that inequality would look like. Otherwise, that's going to look like this. We have $2 for hot dogs. This means that for every hot dog, I get another $2, right? So if I had 3 hot dogs, it'd be 2 times 3, it'd be 6. If I had 5 hot dogs, it'd be 2 times 5 to give me 10 for how much I would make. So in general, we have 2h. And typically means plus. If I say there's you and me and him, how many is that? That's 3. We did that because we added. And then we also have $3 per brat, which is 3b. And we want to make at least $500. When I say the word at least, what does that mean? If I want at least $500, do I want $500 or more, or $500 or less? I want $500 or more. So I want the 2h plus 3b, my profit. I want the profit to be greater than or equal to 500. At least means we include the 500. That's why I have the equal to part below. So our inequality is 2h plus 3b is greater than or equal to 500. Whenever you use variables, we should always define a variable. So I should say where h is the number of hot dogs and b is the number of brats. Now, one thing to note here is I'm going to graph this. When we solve for a letter, I could solve for h, I could solve for b. In a lot of real-world problems, there isn't necessarily an independent and dependent variable. The hot dogs doesn't determine the brats don't determine the hot dogs. So really, we can solve for either letter if we want to when we graph it. With decimals, remember, I can actually graph this as is. I don't have to turn it into slope-intercept form like I would with a TI-84 graphing calculator. So let's do this with decimals. When you do decimals, you're going to want to have x and a y. And again, it doesn't actually matter whether I put 2x plus 3y greater than or equal to 500, or if I said 2y plus 3x greater than or equal to 500. Just make sure whatever way you solve it that you are very clear about which letter goes with which part. So let's take a look at graphing this with decimals. So we have 2h plus 3b is greater than or equal to 500. I'm going to let the x be the hot dogs, plus 3y for the brats is greater than or equal to 500. So I type in 2x plus 3y is greater than or equal to 500. What I'm saying here, I'll take off the minor grid, I'm saying that the hot dogs is h is for the x, and I'm going to do brats b for the y. At this point now, we can have just the decimal screen. And what we're going to do is change our x-axis. I like to go a little bit to the left, so I'm going to do a -25 so we can actually see the labels. And then because 500 divided by 2 is 250, 500 divided by 3 is 166.6 repeating, or 2/3. We're going to go up to more than 250, so maybe 300. And let's count by 20s. Same thing on the y, we'll go from -25. Again, 500 divided by 3 is 166.6 repeating, or 166 and 2/3. But just to make it simple, we'll just go to 300 and again count by 20s. Now, what you see here is on the left, notice that it goes all the way past the into the negatives. Everything above the line is a solution, but we can't have negative brats or negative hot dogs. So one of the things you have to change here is make it so it's x greater than or equal to 0. We can do that by using the little brace in the middle, we're going to use x greater than or equal to 0, and then we have to go hit the ABC again, hit the little up arrow this time to go to the other side, and then use that close bracket. Notice what we've done now is on the left, we've limited it to strictly x greater than or equal to 0. There's no negative hot dogs anymore, because again, can't have negative hot dogs. We're going to do a similar idea with a y. Again, go to the ABC and the up arrow to go back to the left side brace. We're going to go back to the y greater than or equal to 0. Go back to ABC, hit the arrow up so we can go to the right brace. And now we have a pretty good looking graph that we could present to others. It's clean, effective, efficient. Screenshot that and then send it to your document. Now, if we had wanted to, we could have done 2y plus 3x greater than or equal to 500. We would have had y greater than or equal to 0 with the y part, x greater than or equal to 0 with the x part. Just would have flipped this graph around. We would have started at 250 on the y and 166 2/3 on the x. Still would have been shaded to the upper side of the line. I, in the answer key, put all the different ways, including the TI calculator if you'd like. So take a look at the answer key after you submitted this. Again, good just to label what each part is here. Makes it really clear for the reader. It is pretty obvious though because you have it labeled. That's one of the benefits of Desmos. That's why I like Desmos better than the TI calculator. Just a very clean looking graph that you could present to others. Now let's look at part C. Give at least one example that would satisfy this situation. So again, any point in here that's on the side of the blue that's shaded, that's our feasible region. Any whole number answer would work. Has to be a whole number answer. So for example, maybe we could pick the point 140, 100. I see that that is above that boundary line. 140 is the x is the hot dog, so it'd be 140 hot dogs, 100 brats. Should make me get at least $500. If I wanted to, I could verify that by plugging that in. With 2 times 140 plus 3 times 100, supposed to be greater than or equal to 500. See on the left side we get 580, which is indeed greater than or equal to 500. So again, that's a possibility, one of many. So that's just one possible example. Again, you can pick any whole number coordinate as long as it's a positive whole number coordinate. Again, can't have decimals because you're not going to sell a partial hot dog or a partial brat. In some cases, it is possible to have decimals, but it all depends on the context. So the rest of these are going to look something similar to this. Again, you can use this restricted domain to make your graphs accurate and correct. Let's go ahead and try the next one.